And thank you for the two of you that put some comments in the chat. And as we go, we're going to ask people to be interactive so that it makes it more interesting for everyone. So our session today is about science, engineering, and literacy. And we're going to highlight how to use SiE Books in the classroom. SiE is shorthand for Science is Elementary. On our agenda today are some introductions. Then we'll talk about why science is important in early childhood education. Talk a little bit about science in school, what the next generation science standards are. They were developed for elementary school, and at the same time, they're really still useful in preschool settings. We'll talk about integrating science and literacy. We'll do some hands-on exploration with our SiE books, and then we'll talk about the science in them, the literacy in them, and how to extend them in your classroom. And finally, there's going to be some opportunities for a Q&A at the end. So Science is Elementary was founded in 2008. Our mission is to transform elementary science education for everyone. And we do that by teaching students, training teachers, and engaging the scientific community. We want to make sure that every child has access to high quality science education every day. We have 3 pillars. We believe that science is awesome, science is for everyone, and science is everywhere. And we work with students from preschool to 5th grade and also with their teachers. Since our founding, we've worked with about 15,000 students, trained a few hundred teachers, and had about 1,000 STEM professionals as volunteers. I am Tzipor Ulman. I'm the founder and CEO of Science is Elementary. And also on this presentation with me is Jennifer Urmson, who is our program director, and she will take over on this presentation a little bit later on. So we have several programs at Science is Elementary. The first one is an in-class as well, in person, as well as a virtual program for students, where we are aligned with the next generation science standards. In elementary school, we have 100 hours of hands-on science per student. And one of the things that makes us unique is that all of our educators are themselves scientists and engineers, as are our classroom volunteers. And we have some pretty impressive results overall in all of our programs, and some a very detailed one on our website if you want to take a look later. Our professional development programs are customized to each school, whether it's a preschool or a K-5, K-8 school, and we also work with districts. So it's possible to customize programs by the district level as well. And we have a range of offerings, from a one-time engagement, one-time session to ongoing engagement. And there are some more data points on our professional development program. Our SiE book series was started last year at the beginning of the pandemic. It consists of 15 books with an anti-racist lens on science. It's really targeted at pre-readers and emerging readers. At the same time, we have an adult companion with every book that is available in English and in Spanish. The books include step-by-step illustrated instructions, which you will see as we progress through one of them a little bit. And last year, we distributed 10,000 of these books together with the materials kits that students would need to do the experiment to children in schools and in cities all over the Bay Area, from Oakland down to Gilroy. One of our testimonials from a teacher is that Science is Elementary provides rich, engaging instruction where students learn so much each day. Students look forward to lessons and engage in a lot of discussions based on them. And finally, one of the parents whose student received a book said that they like the simplicity of the books, the diversity of the characters, and the drawings that clearly convey the scientific principle. So that's a little bit about us. So now diving into our session. So Frederick Seitz, who is a physicist, said that a good scientist is a person in whom the childhood quality of perennial curiosity lingers on. Once they get an answer, they have other questions. And we thought this was a perfect segue to talk about science in preschools, that quality of perennial curiosity. So why teach science in early childhood education settings? The research shows that STEM thinking begins even already in infancy. Early experience builds brain architecture. Play and hands-on learning help us make sense of complex or abstract information. STEM amplifies language development. And sorry, these are being shown out of order. Mindset really matters to STEM success, and in preschool we start setting mindsets, being flexible and being open. Children's abstract thinking potential can be unlocked through both adult support and executive function skill development, and this is where both families, parents or extended families, as well as preschool teachers and other adults in preschool settings are really helpful. So the next generation science standards, as I mentioned briefly, were developed for elementary schools, for middle schools, and for high schools. And they really wanted the committee that developed it think about what are the components of science that, and what is the framework under which we want to teach science in schools. And they came up with this 3-strand system, which is depicted here in this image as a Mobius strip. And a Mobius strip, if you don't know, is a strip of paper that is twisted in such a way that only has one side. So even though the paper itself that it's made out of, or the material that it's made out of, has 2 sides, there's one continuous line that goes all the way around. And the idea is really that the scientific practices and the core ideas and the cross-cutting concepts, all of these things together are really critical to teaching science. So the first one, which in the Mobius strip is in blue, are scientific practices. And those are things that scientists do every day. And they include things like asking questions, using models, doing experiments, analyzing data, and so on. And preschoolers do a lot of these things every day. We know that preschoolers and even younger children ask questions all the time, sometimes to the dismay of many adults. But that quality, as Frederick Seitz said, of perennial curiosity, typifies preschoolers and also typifies scientists. Preschoolers try things all the time when they play, when they do things together and with others. And doing that is a way that they experiment. And they also talk to each other and try to explain what's happening. Cross-cutting concepts are concepts that are important in science, and those things include patterns, cause and effect, scale and quantity, and so on. And those are concepts that we talk about in preschool as well. If you think of a lot of books that we read and use in preschool, early childhood education settings, a lot of these concepts show up again and again. If you think about, some of the Dr. Seuss books, One Fish, Two Fish. If you think about a lot of books that have shapes in them, or that talk about night and day, or that talk about why things are built the way they are, like structure and function, those are all concepts that are, like I said, important in science and also important in everyday. And finally, the core ideas, which is represented on the Mobius strip by the orange, is the science content. So that would be the physics, the engineering, the biology, the geology, and so on. So overall, integrating science and literacy, what does that mean? In a preschool setting, we can use relevant storytelling, right? So, and we'll go into a specific example in a moment. We really want to make sure we harness that preschooler curiosity, allow them to ask questions, help direct their questions, encourage productive scientific preschooler behavior. So those are things that, again, we mentioned earlier in terms of doing experiments and talking to each other and trying to explain their findings or their thinking. Hands-on exploration, which is a key part of preschool. Another way to think about it is a play and directed play, and then conversations and data recordings. And so we're going to now take a specific example and use SiE, one of our books, the SiE books, to see how to put this into practice. I'm going to turn it over to Jennifer now.
Hi, I'm Jennifer. It's nice to meet you all. Thanks for joining us. I'm going to take you through one of our books right now called Jasmine and Jose Build a Playhouse. And you will all get a link to a PDF of the student book and the adult companion at the end of the session. So don't worry about trying to remember what it looks like. You'll get access to it afterwards. And as Tzipor mentioned, all of the books do have an adult companion with them. So we can go ahead to the next slide. So this slide is showing the first 4 pages of our student book. So what I would like you to do right now is take a look at the pictures and see what you get from the story from the pictures, and add your thoughts to the chat. So what's happening in these pictures? And I will be asking you guys to add some comments in the chat because we really like to have discussion, and we are missing being able to talk with everyone in person. So what's going on in these pictures? Can you tell what the characters are doing? And what kind of materials do you see?
They can think about how to visit the table.
Okay, thank you. Lori added in the chat, the kids are trying to follow a diagram to build something out of wood. It was unstable, so they're trying to figure out why. That's awesome. That's almost exactly what we have in our guide. Trying to build a table, it looks like. Thank you, Joanne. So in our story, they're actually trying to build a playhouse. It does look very much like a table. So they have made a diagram of what they want to build. They made a plan. They found some materials, and they built their structure according to their diagram. But when they went to get some pillows, what happened to it? It fell over. It started to tilt. So then they sat down to think about what could they do to make this playhouse more stable. And now we're going to move on to a hands-on part of the book where we're going to actually do some experiments to see if we can help them answer their question. So these are all the materials that we need to do the experiment. And I know we sent out a note to everybody a little bit late, maybe about the materials, but I hope you might have some with you. So we need some toothpicks and marshmallows, and I've got a box here, sort of like a table to help us out. So how many toothpicks do we need? You can either count them or read the number. You'll see that we need 18. And how many marshmallows do we need? Again, you can count them or you can read the numbers to see that we need 12. And this can be an activity you can have your kids do with the counting to make sure they have all of their materials. Okay. Okay, can we go to the next slide? There we go. The first thing we're going to make is a triangle. So you can see here we've got the visual instructions on how to build the triangle and a chance to talk about things like how many sides does a triangle have? So how many toothpicks will we need? Oh, 3 sides, we'll need 3 triangles. And I'm going to build it just a little bit quickly here for everybody watching. We can follow along with our 3 toothpicks. How many corners does a triangle have? 3 corners. How many marshmallows do we need? 3. And here we go. We can build our little triangle. Okay, and the next shape we're going to build is a square. So again, we can talk about how many sides does a square have? 4 sides. How many toothpicks will we need then? We'll need 4 toothpicks. How many corners does a square have? 4. So how many marshmallows will we need? 4 marshmallows. And we can go ahead and build our square out of our toothpicks and marshmallows. Oops. Okay, so here's our square. So now we've got our 2 shapes and we can test them out. So what we're going to do is try pushing on them a little bit. You can see in the drawing a little arrow. Let's see what happens if we push. I mean, kindergarten, we're using the word force because they've already been learning about force. So what happens if we use some force on it? And what do you observe? What happens when you try pushing on your triangle? And if you are not building, if you're just watching, I hope you can observe that it's really keeping its shape. It's not changing very much. Then we can do the same thing with our square. Let's see what happens if we use some force on the square. And here we can see that the square doesn't keep its shape. The square moves around quite a bit. Okay, so we can see that our triangle is much more stable. Oh, there we go. Somebody's making our square and triangle. Excellent. Now we're going to take our shapes and we're going to build them into structures that stand up. So the first structure we're going to build is a pyramid using our triangle. So you can look at the picture. How many more toothpicks will we need? And we can see we need 3 more toothpicks. So let's see if I put this here where everyone can see. I'm going to add the toothpicks. And I need 1 more marshmallow on top. And now we have our pyramid. And we can talk about the word pyramid. That might be new for our kids. We can make observations about the pyramid. What do you notice about the shape on every side? Our pyramid is made of triangles on each side. Now let's make a structure out of the square. So we'll start with the square. We're going to turn this into a cube. So first I need 4 more toothpicks. Here we go, 4 more toothpicks. Then I'm going to need 4 marshmallows and 4 more toothpicks again to build up my cube. So the structure we're making out of a square is called a cube. We're adding some more of that vocabulary in with the kids. We're counting. And here we go. Here is our cube. So we've got our pyramid all made out of triangles, and we got our cube, and we can notice that the cube is made out of squares on each side. Now we're going to test our structures. Same thing we did before. We're going to apply a little bit of force or push a little bit on the sides of our pyramid, and let's see what happens. What do you observe? That pyramid's really keeping its shape. Now let's try the cube. If we use a little force, if we push on the cube, what's happening? It's not keeping its shape. We can even try dropping them and see what happens. Maybe stand up, drop it on the floor and see which one keeps its shape. And we can see that this pyramid is really much more stable than the cube. Now we can say to the kids, well, why do you think the pyramid is more stable? We can notice that triangles kept their shape, and the structure made out of triangles or the pyramid also kept its shape. Squares didn't keep their shape, and the structure made out of squares also didn't keep its shape. Okay, so now, let me push that out of the way. Now let's go back to Jasmine and Jose's story. We can remember that Jasmine and Jose were building their playhouse and it wasn't stable, it wasn't standing up. So now that we have done some experiments with our shapes, how could we help them? What could we do to help Jasmine and Jose? And here we have a spot for kids to come up with their own solutions. Can you draw a stable playhouse or come up with your own idea of how we can help them? So once they've thought about it, come up with their own, now we can see, here's what Jasmine and Jose did. So Jasmine and Jose learned that triangles are more stable than squares, and they thought about how to add some triangles to their playhouse. And what they did was they added some extra wood diagonally across each wall of the playhouse, and it made triangles on each wall. And we can point out, let's look at each wall. You can see now where there's a triangle shape in each wall. And now their playhouse is standing up. Hooray. So what's the science that we're using in this story about Jasmine and Jose? If we think back to our next generation science standards and the scientific practices or things that scientists do, we ask questions. In our discussions about them, we're asking questions of the students and encouraging them to ask questions about the story, about the structures, how can we fix things. We are also using models. So we built models of the different shapes to test them out and see which ones were more stable. We can argue from evidence. Why would pyramids be stronger than cubes? We saw we had evidence that triangles were more stable than squares. So the pyramids made out of triangles were more stable than the cubes, which are made out of squares. And communication was another one where we're having the kids talk about their ideas, about what they've learned, sharing their questions. So lots of practice with that. Then if we take a look at the cross-cutting concepts that we're thinking about, patterns is a great one. So we saw that squares change their shape, triangles don't. Structures made from squares, therefore, are less stable than those made from triangles. If you're doing this in your classroom, you will have a whole group and they will all see that the squares changed their shape and then the triangles didn't. So you can use that as a pattern also. Then we're looking at cause and effect. When I use a force or I push on the cube, that changes its shape. If your kids have already been talking about gravity, they can talk about how gravity is what's pulling the playhouse down and making it lean over. And structure and function. The kids in the story are trying to build a playhouse. It needs to be stable so that they can go inside. The playhouse that they built first, when they started with something like a cube, wasn't stable, so it couldn't function as a playhouse. Therefore, we needed to use some other shapes. We needed to change the structure to make it more stable. What about some literacy connections to Jasmine and Jose build a playhouse? Well, in addition to starting with a book and learning about how books work and looking at things from left to right, you can have the kids identify the beginning, middle, and end of the story. We can have them connect the story that you're telling them with the illustrations if you're reading the story to them. You can have the kids tell the story by looking at the illustrations, sort of like I asked you to do at the beginning. We want them to understand that the illustrations are referring to real world objects. So in the instructions for construction, the toothpicks and marshmallows are referring to the actual toothpicks and marshmallows that we're going to use. You can have the discussions in small groups or class-wide discussions about the story and improving their communication. And we can work on vocabulary development with the different properties of the materials. You can talk about the marshmallows, the toothpicks, whether things are straight or curvy, hard or soft. We can also introduce our vocabulary around the shapes we're using, triangles and squares, pyramids and cubes. And you also probably heard me use the word stable quite a bit, meaning that it keeps its shape or it stands up on its own. So lots of opportunity there to add in their more vocabulary as you're discussing with them. Oh, and sorry, I just saw there's a question about, besides marshmallows, other recommended materials. So other things that we could use, now she mentioned they can't use food. We could use bits of Play-Doh. You could use some other connectors. We've definitely done it with little circles of Play-Doh. Other food options would be raisins or dried cranberries work pretty well. Oh, someone else has suggested raisins. It's a good option. But clay or Play-Doh works pretty well if you're not allowed to use food.
Yeah, I think, thanks for that question. I think that there's also some soft foam balls that you can use that would work for this purpose. Another thing to consider is that sometimes toothpicks themselves, if you're working, for instance, with 2 or 3-year-olds, it might not be such an easy thing to do. And so you might consider using longer rods, either coffee stirrers, the plastic ones, or the rigid ones. And then certainly, as Jennifer suggested, Play-Doh or clay could be a great idea. And some of the foam that is used for flower arranging is foam that is very rigid, but that you can stick things in. So those are some options. And the rest of you who are in this session, if you have some other thoughts, please do add them in the chat.
Okay, so we also have extension ideas. So if you're using something like this in your classroom, it doesn't have to be a one-time thing. You can keep building on that. And the very first thing, of course, is you can just keep on building. You can ask the kids to add on to their playhouses or try building if they have drawn an idea for a playhouse. Now they have their materials out, they can see if they can keep building that. You can try it with different materials. You know, what happens if we try to use spaghetti instead of toothpicks, or what happens if we use bigger marshmallows instead of smaller ones? And there's a good opportunity for you also to be talking about the properties of the materials and bringing in some of these words like soft or rigid or hard, brittle might be a good one. You can challenge them to make the structures larger and see what happens. How can they make it stable if the structure needs to be really big? And then you can just have them building with other things in the classroom, building with blocks. You know, how do these ideas work when you are building with other materials? You can have the kids drawing diagrams. We had one in the book for them to build their own or draw their own idea for the playhouse. But you can have them draw a diagram of the shapes. They can draw a picture of the materials that they're using. You can have them color in the images in the books as you're going through to reinforce the story. You could read The 3 Little Pigs and talk about how the materials affected the houses that the pigs made. And you could have the kids keep going, make up another story about Jasmine and Jose that they could draw. And you can play I Spy using different properties of materials, or even playing I Spy using some of the shapes that we talked about. Where do you see some triangles? Where can you see squares? The playground is a great place to look for examples of triangles and squares and structures. Where you are, you may be able to find some examples of triangles reinforcing supports. You might see triangle shapes underneath desks or in the rafters and things like that. Okay. Oh, and then we had a question about, so how could you extend what we did today into an early childhood classroom, either your classroom, or if you're still a student thinking about what you would like to do or how you imagine your classroom working. And we have a comment from Lori that with a 6th grade class, they need a bridge of toothpicks and glue. And they had a competition about whose bridge held the most weight. That's an awesome competition. We have made bridges with younger kids without the glue, but it's always really a fun challenge, especially when there's some kind of a competition involved. The kids get really excited about it. All right, if anyone else has any thoughts about, you know, how something like this could work in your early elementary classroom or your early childhood classroom. Okay. I think we're just going to open it up to questions, and I'll use the iPad app on the night sky. I'm going to open it up to questions. You're welcome to type your questions into the chat, or you can just go ahead and ask your question verbally. It's fine too.
Yeah, so one thing to think about is those of you who maybe are not in classrooms yet is as we mentioned, we're using toothpicks and marshmallows, right? What are other materials that we can use in an early childhood education classroom that would get the same idea across, right? What Jasmine and Jose are doing in the story is discovering that triangles are stronger than squares. Where in your classroom, or as you've been, if you're not teaching yet, perhaps if you are observing in classrooms, or perhaps you're remembering from other experiences you've had with kids in the early childhood age, where are places that you can point out triangles and squares? What are materials in the classroom that you can use to reinforce these ideas? So let's kind of brainstorm together, and please don't be afraid to share. No idea is a bad idea. Great, so Joanne says she's going to use Play-Doh or clay and different shapes. So that's a great idea to continue that. Anyone else? Great, the tables that the children are using. Do you want to say a couple more words about that? What are you, tell us what you're thinking. I mean, I think I know what you're thinking, but if you could either unmute yourself and say something, or if you want to type it in the chat. Yeah.
So talking about the tables they're using, like what shape are they? Are they square or rectangular? I wonder if that was just a suggestion to make observations. We often like observing the tables, and we often find, at least in the school tables, that they do have some reinforcements underneath that are triangular. And Alan D shared that they have used hot glue and popsicle sticks to build structures to see how many magazines they could hold up. That sounds like fun. I'm wondering what age that was for. That sounds like a fun activity to make it more stable. And suggested using larger items like straws instead of toothpicks, especially for the younger kids. Yeah, talking about the meaning of shapes while you're doing it, right? What does it mean for something to be a triangle? Especially if you take a look around at what things can you find some triangles? What do they have in common? Do they all look the same? They might be different sizes, but they all have 3 sides. You can talk more about shapes while playing with blocks. Yeah, thank you.
All right, well, since we seem to have a pretty quiet group today, I think we can wrap it up. Thank you all so much for joining us, and feel free to contact us. So I'm just gonna put this back here. We're going to be sharing the slide deck with the organizers and with you all later on today. And as you can see here, there are some links at the bottom. If you want to read more about SiE Books, there's a link there. And then The book that we showed you today, the PDF of that is online, as well as the adult companion in English and Spanish. And those three are, we're distributing them free of charge. So feel free to use them if it'll help you. You're welcome to make copies of them for your classroom. Please just be sure to acknowledge us when you do that. And thank you all again very much. And we hope that one day we can all do these things in person again.
Thank you very much. I enjoyed it.
Thanks.
Thank you.
Bye.
Bye.